In this episode, we're going to do Mailbag, a device sent in by a viewer for me to take a look at and see if we can make it work. Today's little gem is a beam index color CRT viewfinder from a Hitachi camera. And we're going to see if we can get a picture on this thing. I received this little CRT viewfinder in the mail today. This was kind of neat. This is a Hitachi. It came out of a Hitachi camcorder, and it's a color viewfinder. Like my Panasonic 1-inch color TV, it's 1.5 inches, which makes it the smallest color picture tube made. The difference between this and my little Panasonic is that this is a beam index tube. The Panasonic is a conventional CRT, which makes it more unique because it has 3 guns in the neck. It has 3 filaments, 3 cathodes, 3 electron guns, 3 cathodes, and it has a shadow mask. This does not. No shadow mask on this tube. Single gun, single filament. For all purposes, this is a black and white tube that produces color. And how they do it is by timing the beam, so that as the beam travels across the screen, it hits the red, green, and blue phosphorus stripes, and the timing circuit here knows where the beam is. This is something that Sony called indexatron on their tubes. Hitachi, it's just a beam index tube. Now, the big differences between the Sony indexatron and other companies was you need a reference signal to tell the circuitry where the beam is. And how they did that, in a conventional color picture tube, you've got your screen, and in the back of the tube you've got 3 guns. An inline gun would have the 3 guns in line like that. And then you've got a shadow mask, which has got a bunch of slots in it. And as the beam is scanning, the beams do this. The beams cross over each other. And as the beam is scanning, you've got your 3 beams that are focused on their specific phosphorus stripes. In the front of the picture tube, if you were to look at the front of the tube, it's got a series of stripes, right, like this on it. This is what's called an inline gun. So then you got your red, green, and blue. Red, green, and blue. The other type of tube used a delta matrix. So if we looked at the electron gun, there would be a red, a green, and a blue forming in like a delta matrix, a triangle. And the screen was made up of dots, and it would be like this: green, red, blue, and then green, red, blue, right? And then green, red, blue, etc. But they always formed in that little pattern like that. So that you'd have all your dots lined up like this, and then the row above it would be, but they were made up of little dots. The little Panasonic CT101 is this type. It's a delta matrix type tube. The third type of tube is called a beam index tube, and that's what this is. The beam index tube, again, has your stripes on the front. Sony did theirs a little bit different. Sony used 4 stripes. This one, I believe, only uses 3. Sony used a red, green, blue, and then a UV, and then a red, green, blue, UV, red, green, blue, right? That's how Sony's were. And inside the bell of the tube, on Sony's indexatron tube, they had a little sensor that was mounted on the back side of the tube here. And some of them actually had 2 little sensors on the back side of the tube. And as the beam was scanning, this ultraviolet stripe was actually on the back side of the tube. So it would actually shine into the bellow of the tube every time it was hit with an electron beam. It would emit a flash that was picked up by these detectors that were on the inside bellow of the tube. Look up my video called Sony Vitamagic if you want to see a beam index, one of Sony's beam index tubes in a projector configuration. I have one, and I've done a video on it. And that's how Sony's work. Now, Hitachi did things a little bit different. They didn't, as far as I know, didn't have the ultraviolet. They had your standard red, green, blue, red, green, blue, etc. Right? So we need a way of synchronizing the circuitry. So what they did, and this is going to probably prevent me from being able to get a color picture, if anything, off this. We're going to try and hook it up, but I don't know that I'm going to get anything off this, even if I get power to it, because there's a key component that's missing. On the Hitachi, they had another little piece that sat in front of the tube, and it was basically a little detector that had a photodiode on it that was sensitive to a specific wavelength of light, either red, green, or blue. I don't know, but they have a little sensor that sits there. Actually, I think it had two little sensors on it, if I remember. In the viewfinder, it would sit. This is the viewfinder, and it had a mirror. So if this is the viewfinder here, and the body of it, here's the body of the camera, and then your eyepiece was over here, right? And then this is the shape of the actual unit. Your eyepiece was here, you had your magnifying lens here with your eye cup, and in the back here there was a mirror that would reflect the image from the tube to the eye, and then there was another little piece that sat down right here that was facing at the tube itself, and that was the detector that would detect whatever specific stripe it was looking at, whether it was the green or the blue or the red or a combination. Because it did have two detectors on it, one might have been looking at the red and the other one looking at the blue or the green. But there was a detector that would detect as the beam scanned the front of the picture tube, and it would provide a signal back to the control board to time the arrival of the color signals, because the color signals will be switched red, green, blue, red, green, blue, red, green, blue, one color at a time, and that would come off of this circuit up here, I believe. Anyway, I didn't get, this was donated to me, but I did not get that detector, and I believe it probably plugs in to this plug back here. That's more than likely where it plugs into, and it's probably still sitting in the rest of the viewfinder that's been scrapped. That I don't know. You know, maybe the person that took this apart thought that that was just a little tally light and stuff, because I believe this little piece here that was, remember this is sitting like this, I believe this had little LEDs on it that would shine this way, that was picked up and sent to the operator, would have like the red light when you were filming, or the yellow light when your light level was too low. It had the actual little indicator lights on it on one side, as well as the detector facing the tube. And maybe the person that took this thing apart thought, oh, that's just the eyepiece detector and it's nothing else, but it's actually part of the circuit to make this work. So I don't know that I'm going to be able to, I might be able to get a picture on here, but I may not be able to get a color picture. That's what I'm thinking. But I have no info on what wires do which, so I've got to try and figure out which ones do what on this thing. We'll try powering this unit up. First things first, I need to figure out which is the ground wire. And then we'll try and figure out which one of these is a power wire. Looks like somebody's been soldering on this too. Look at this. Looks like this trace has been maybe repaired here. Somebody's been doing some work on here. Anyway, it'll be interesting to see if I can get this thing to fire up. So I'm going to look and see if I can find which one of these wires is ground. I will assume that the black wire is ground. That's usually a good place to start. So we'll just put put the meter in continuity mode, and I'll touch the black wire and touch something that I assume is ground and see whether I get anything, which I'm not. So maybe the black wire is not ground, because I should have continuity. So like other cameras, other viewfinders, they don't necessarily use the obvious color for ground. So we'll just see which one it is. We'll just strip them all. I may have to break down and try and find the service manual for this. I gotta figure out what model of camera it came from first, but ground. I know that the shield is going to be ground, so let's just see if any of these wires are grounded. Yellow I would think would be video in, but who knows. White ground? Okay, so there we go. The white wire is ground. Go figure. Now, a unit like this came off of a color camera, and I'm going to assume that the operating voltage is about 12 volts. So I'm going to just set my power supply to 12 volts. I'm going to set my current limiting relatively low because this thing's not going to draw a lot of power. So I'm going to set my current limiting to maybe a half an amp. That way, I shouldn't have enough current to do any real damage if I hook it up wrong. So let's hook up the black wire, or the ground, to the white wire here, and then we'll see whether we can power this thing up. And I'll just try some of the other wires here just to see whether I can. I'm looking for any current draw, right? Okay, 0.1 amps. That's probably, that could be, the yellow wire might be the power. See if anything else draws any power here. Okay, the only one that draws any type of current whatsoever, it's 100 milliamps, is the yellow wire. So I don't see any light. Oh, yes, I do see some light. I see a white line. We have no vertical deflection, but we've got power. So that means we've got high voltage, and we've got the right leads here. Now I don't know whether this silly tube is or this monitor is driven with external sync signals, or whether it's it probably just takes an NTSC signal to make it work. So, oh, I'm getting something. It's doing something. I've got a little bit of raster down it now. At least we know that the tube is good. I'm just going to try and give it a video signal and see whether I can coax any type of a signal out of this thing. So I'll make sure that my DVD player is playing something. We know that the black is going to be our ground, so we'll just connect that there. Oh, now I got a full screen. Now I have a full screen. And maybe the blue wire might be the input. Got a raster. Got to get a video signal coming out of my my Blu-ray player. Okay, the wire that's video is going to be the orange wire. Looks like we're maybe don't have the right ground reference here. Let's just see whether one of these other wires is my video ground. should have a video signal on here now. I don't have my ground though. When I ground my... Oh, that's better. There we go. We have a picture. We have a picture. It's of course backwards because it's meant to be looked at through a mirror. But let's just let the next video play. We have a black and white picture. I don't think we're going to get color unless I can come up with the synchronizing signal to synchronize this color sync. I don't think we're going to have any luck at getting any color on this thing. I should flip the horizontal yoke around so that the picture is facing the correct direction, but right now it's a mirror image, but we've got a picture on it, which is good. So now I know which wires are what. I'm just going to cut off the ones that I don't need because we don't need to get them confused or shorting anything out on this unit. Orange is video, white is ground, and yellow is power on one of these little monitors. A couple more adjustments here. What did they do? Color contrast and tint. Well, again, without reference, I don't think we're going to get anything. Yeah, we can see the color signal on there, but it's not going to do anything unless we have our reference. You can see the color signal, but it's not going to lock. So now what I need to do is I need to figure out what exactly, whether it's just a photo transistor or what we need to put to pick up that signal and feed it down to, I'm sure it goes down to this connector at the back here. Or I could just turn the color off completely and have it as a black and white monitor. But it would be nice to actually get this thing to display a color picture. Which controls that I'm tweaking. It's contrast. Let's flip the yoke wires around just to get the picture straight on this to have it the right way. Should I just take a wild guess as to which one is the horizontal and which one's the vertical? Let's take a wild guess. I was just thinking, the guy that sent me this, I'm sure he's probably going to see this video. If he's still got that rest of that viewfinder, if he's still got that little sensor, maybe if he sends it to me, I can set it up in front of the tube and actually get the thing to synchronize, and then I'll have this the world's smallest beam index color tube to go with my world's smallest conventional color tube in the Panasonic. Each are kind of neat in their own way, right? I still don't think it's anywhere near as cool as the little 1/2-inch black and white tube, though. That one there is. That one's the coolest of them all, just because of the size of it. But this is cool in its own respect, because it's a beam index tube. This was also sometimes called the Apple tube. And the Apple tube means absolutely nothing to do with Apple computers, by the way. That was, I think that was a Fleetwood, if I'm not mistaken. That was their trademark. Was they called it the Apple tube way back. And they actually tried to make this thing a commercial success. The idea was to try and get away from all the convergent circuits and stuff that were on a conventional picture tube. So whoever could make a single gun color tube, this goes back to the 1950s, but that's what the end result was they were trying to make a single gun color picture tube. But they ran into a lot of technical hurdles because back then the circuitry required to time it, they hadn't developed the good phase lock loop circuits like were developed later on to time the circuit. So back in the days of tubes, it was not a very reliable way of doing it. So it was kind of abandoned by most of the manufacturers. Sony picked it up and developed the Indexitron, which is the same type of tube. But Sony did that, and a couple of other companies got involved and made beam index tubes as well. Where they were mostly used was in aircraft and stuff for displays, because they couldn't have convergence and geometry problems. And the problem with an airplane is that, of course, this is long before we had LCD screens, but the problem being in an airplane is that the magnetic field is always changing because, of course, the plane's flying, right? So conventional tube, the problem with a conventional tube was convergence problems. So they really kind of developed, a lot of it was developed for aviation, for color readouts in commercial planes. And then, of course, Sony pretty much perfected it in their small little color Indexitron TV. And then they had their Indexitron projector. I'm just using a minuscule amount of heat shrink on here. Waste not, want not, right? Okay, now this thing should display the picture the right way around. Yeah, it looks a little better. At least I didn't get the vertical reversed, or we'd have an upside down picture. Okay, now I've got a nice black and white picture, relatively nice black and white picture on this unit. I'm getting a little bit of ingress here just from my cables, but if I can find a sensor for the index signal, then I should be able to get a color picture off this. Sony did it right. They put the index, as they say, they put the index detector, they mounted it right to the side of the picture tube. So they have actually had it. This one's probably got the full anode in here. I'm poking my finger around here where there's probably 5 kilovolts on this thing, maybe more, being a color tube and all. But I bet you there's 4 or 5 kilovolts on this tube. Sony, with their tubes, there's a small portion on the tube itself where they didn't coat the inside with the anode silver material, so it's clear. So if you saw my Indexitron projector, I showed a shot of the tube, and it's got a section of it that's clear. And they did the same thing for their little 3-inch Indexitron tubes. There's a little patch on the side where the detector is attached right to the side, and it's clear. You can actually see right into the tube itself. And that'd be nice if that could be done on this one, but I don't believe so. That's why Hitachi did it this way. Was they just had to do things a bit different. They probably couldn't put the detector on the bell of the tube because it probably has something to do with Sony's patents for their Indexitron design. So anyway, there it is. A small 1.5 inch. This would be a 1.25 inch viewable picture, but the tube itself is 1.5 inch if you measure it. I think it's 1.25 inch. Viewable screen. My Panasonic one's slightly larger. It has a 1.5 inch viewable picture, but of course superior color in every way over this one. But these weren't bad. They were trying to get color viewfinders on some of the early camcorders, and this was one of the ones that they did that with. This was Hitachi's design. Again, the Panasonic 1.5 inch Delta Matrix tube. That was Panasonic's professional camera division developed that. That was something they were working on for broadcast type cameras, but it never really, I don't think it ever got off the ground. But anyway, that's this thing. Not much else to show you guys on this video, because we have a picture. And if I come across a detector where I can actually make this thing and display a color picture, we'll do a follow-up video at that point in time. Actually, looking at this unit, looks like this was where it probably plugs in right here. There's two connectors that don't have anything on it. One's this one back here, and the other one is this one here. This is probably the one where the detector, I'm thinking, plugs in. Oh, there's a couple more controls on the back too. I wonder what they do. Let's just tweak controls and see what happens. See what it does to the picture. Horizontal hold. And this other one, probably vertical hold. Not vertical size. That one's vertical size. What else is back here? I think it's just those two. Horizontal hold and vertical size. What else is on this thing? I don't see any other controls that are... Oh, there's a couple of switches on here too. What do these switches do? Let's flip some switches and see what they do. I don't seem to do anything. I'll have to we'll have to see if I can figure out what this used as a detector, whether it was just a standard photo transistor or what. But I get the feeling that it's probably, from pictures I've seen of it, it looks like it's well, it almost looks like an infrared detector actually. The unit that when I saw a picture of it, it almost looks like the type of detector that's in a PIR, passive infrared alarm system. That's what the device looks like. I've only seen a picture of the viewfinder, the inside of a viewfinder, and that's kind of what the device looks like. It kind of looks like an infrared. So it may be detecting the red stripe, the red pulse is what it may be detecting. I'll have to do some more research on that to see what exactly it is, but that is something for another video. We got picture on this now. That's all that matters, right? Thanks for watching, and we'll certainly catch you again real soon. And we may be getting another look at this thing if I can figure out how to get color on it. Thanks for watching.